Okay guys, welcome back to another lesson with Mr. Clark, and we're looking at features of glacial deposition, and more specifically our last feature of glacial fluvial position, which is part of the lithosphere unit and glaciation, and we're looking at an esker today. So just to recap a little bit, a learning intention is to identify how features of fluvio-glacial deposition are formed. Our success criteria is you can explain the formation of a fluvio-glacial deposit. In this case, it's just an esker, although we'll mention a couple other bits and pieces. And I can use annotated diagrams to help me explain these features and can use the right terminology. Another word for that is nomenclature, actually, if you've not heard that before. Nomenclature just means the right different terminology about a subject. You can use the right terminology when explaining these features. So fluvio-glacial landforms, there's quite a few of them. We're no longer at higher cover any of these other ones. Back in 1998, I think it was, when I did my hire, you certainly did look at a lot of other features, and those are some of them, and I might mention a few of them. And you just need to know about eskers for the current hire. Watch that video there from about 8 minutes. You get to see a guy walking around on a glacier and talking a little bit about the amount of water that's there. It's quite interesting. So moving on, an introduction. Fluvio-glacial deposits. Turn my sound down. Fluvio-glacial deposits of materials are different from till. Remember, they're sorted and stratified, and because they're transported by water over longer distances, they're much rounder. Okay, and they're usually sand and gravel. So we mentioned that in the last lesson. Remember, we're just looking at eskers. If you remember the slide from the last lesson, an esker is the ones you need to know, along with terminal moraine and a drumlin from just dropping off the glacier. So today's feature is just formed by water from meltwater in the glacier and the glacier as well, creating the shape. So it's water and the river or the water in the glacier and the glacier that help form the esker, which is different to the terminal moraine. And the sediment drops is different in size and shape. So if you remember, drift is what we're looking at in this lesson. Till is unsorted material, but drift is very sorted. Quite often it can be in layers, and it's transported by the glacier and deposited directly from the ice or by the running water coming from the glacier, emanating from the glacier, and that just means coming from the glacier. So eskers themselves, they're found under the ice. And they're basically streams under the ice, and when the glacier goes, you're left with this snaking ridge of sediment, and how that works is what you need to explain. They're loaded with sand and gravel, and they're carried by the meltwater from the glacier. So as the ice sheet goes away, the glacier goes away, it drops off its load, leaving these ridges. So you don't need to copy anything yet at all, just have a little listen. There's a glacial sort of conduit or a tunnel, water rushing out of it down here. This isn't ice, this is water. So there's a lot of sediment, just like in a river, that you'd be coming through the glacier. There's an even bigger one, so huge tunnels underneath the glacier. So they're long, steep-sided, they wind, they twist and snake, and they're a ridge. They're made up of sand and gravel. As these pictures will kind of show you. So I've highlighted this one here, and this one snakes off way into the distance. Right over into the foreground, but I've just highlighted the front part of it there to show you that there's this ridge shape. And glacial, this would have been a nice sheet. Glacial ice would spread across this whole landscape, and then when it's melted, that's what's been left behind. So you can see that sort of shape, snaking shape. What would have been around that ridge at the time when the glacier was there was solid ice. So in actual fact, the river would have been above the ground because the ice is holding it inside. And that's why when the ice melts, suddenly it's a ridge instead of being lower down in the landscape. That's why it's on top of the land. You can see here a road's been cut through an esker. And you can see it's still a sinuous ridge. Sinuous just means waving or snaking. You can see the size of some of these things. They're huge. They can be huge when they've been under ice sheets, which are maybe a kilometre or a mile thick in some places around the world. They have been. And you can see the types of deposits of sand and gravel. And quite often they're in layers because it's basically like a river. You can see a distinctive layer at the top there of kind of coarser sediments and a band of different materials here. So you can get your eye and see that. And the other stuff is this is at the bottom, this is kind of scree, which has dropped off from the slope. You can't see a fresh exposure of sediment. There's a bit of further reading from Cool Geography website if you want to read about these there's many different forms of reading about these different features, including eskers and came terraces. This diagram is quite good. It shows you that idea that I was talking about before, is the glacier is here, and you've got this tunnel where the river's flowing. In actual fact, it's above ground level, but the ice stops the water flowing towards the ground, so it means the sediments that drop by the river are kept much higher than the surrounding ground. That's why when it melts, it leaves this ridge behind. So that diagram shows that really well. This is a moulin. A moulin is a glacial conduit or glacial hole where water that's melting all around the glacier can flow down. And you get streams on top of the glacier, in the middle of it, a little network of streams within the glacier. It's constantly melting in different places. And that can end up leading to carrying some of the sediments that are within or on top of or underneath the glacier along. So that's what a moulin is. And they're essential in helping that water come towards creating this underground river, if you like, which helps form the esker later on. So here's a picture of world-class eskers at McDonald Lakes north of Atlin in British Columbia, Canada. So I can take that off the internet. And you can see the yellow dots show these sinuous shaping, weaving tunnels. And it kind of shows that there's loads of water under the ice sheet, loads of little rivers, if you like, or streams that have been carrying sediment that's been worked by the glacier. So watch this little clip about moulin, came, and esker formation. Esker is one you're interested in, that'll help you. I don't need to worry about too much about this diagram, but it does show you that if ice was on the left-hand side, your eskers, what would be formed underneath the ice, and a came, as you'll see in the video, are ridges of sediment as well, but they're not formed from underneath the ice. It's the reworking of sediment by the meltwater. There's a model answer. They've actually there's a diagram down there as well I put on to help you. You might want to have a think about that as you're creating your own little answer for creating a model answer for an esker. And I suggest what you do is you have a diagram and you put your annotations around it, as we've done for all the features of glacial erosion. I'm going to leave that for you to do as your own task. But I want to see these two diagrams. You can take annotations on or off as you need them. But I want a simple 2D diagram, and I want you to create your answer using or rephrasing some of these terms around your diagrams, and to submit that as your piece of work or main piece of work for today's lesson. And to use the marking scheme, use the diagrams there or another diagram if you want to, but keep it 2D, keep it simple. There's no need to use colour. I know there is one of you who creates beautiful diagrams, but you don't need to use colour on this occasion, as great as they are. Kettle holes. This is not an exam. This is not a feature you'll be asked about, but I'll just kind of talk to you about a few different bits and pieces. They're holes or pits in the landscape, and how they're created is you've got a block of ice sitting after the glacier has been melting away and what we get happening is the rest of the glacier is dropping off its sediment. It's being washed out by the glacier, and it drops all these gravels off. And what it does, it just leaves a pit in the landscape where the ice is still melting and isn't filling up with sediment like everywhere else is. So it means around about you have left this kettle loch or kettle hole. So there's some other examples and photos here. One from Iceland there, and there's a little video to watch about kettle hole moraines there as well to help with your understanding. This is how they form. I'll let you read that yourself on the Google Slides, and there's a diagram to help with that. And normally I would have an explanation around that if this was a feature in the exam, and it really shows this dead ice, partly buried, and then the outwash plains bringing out the sediment around it. And once this is gone, you've left with a higher land level than when the ice was dropped off. So we get a loch. An example of a kettle loch in Scotland would be the Lake of Menteith, one of only 2 lakes in the whole of Scotland. The other one is right near us, called Lake of Persimmon. So just 2 lakes in Scotland, an English word for a loch. So we have 2 lakes in Scotland, but one of them, Lake of Menteith, is a kettle loch. Outwash plain, I've talked about these before. They're just where this melting glacier, or the water from a glacier, is coming out, and it's pulling out all this glacial drift and sediment and glacial flour, and it just braids and moves the sediment about. And we know that as an outwash plain, sand and gravels. Leave that out there. There's another picture of a glacier from above. You see 2 valley glaciers coming together, a medial moraine sort of here, although back to being a lateral moraine. You can see the landscape there, the rock's really grey, and that shows you the height that the ice has once met and been up to, really. And it kind of alludes to the idea a lot of the glaciers around our planet are melting. They're not the size they once were. And this is millions of tons of ice that has been melted and disappeared and will change the face of our planet and the availability of water and freshwater resources. So this is Colonia Glacier in Chile. Outwash plains, again, how they formed. I'm not going to go through that. I'll let you have a read of that for yourself, for your own learning. Braided streams, again, are not part of the higher course either. There is an example left in Scotland. There's only one truly braided river in Scotland, according to one of my lecturers at uni from many years ago, and that is in Glenfeshie, which you can go to on the way up towards Aviemore. And all the braided river is literally like braids of hair, lots of little streams, or a river running, lots of little streams, as it is on the left here or the right, working sediment along. A cane, your last feature, not in the exam as well, is a hummock composed of layered sand, stratified sand and gravel laid down by glacial meltwater. Terraces, I'm going to let you read that yourself. Normally I show you a flip chart and we do some labelling of key features. We'll maybe do that if we get back into class. Little diagram of some features for you to have a little think of. And I want to show you this last little point. It's a task we do normally do, and identify some of the features. So hopefully on that diagram you can label at least 3 of the key features that we will talk about in an exam. You should know what they are. There are 3 of them, and hopefully you have been able to do that. So if you pause and then unpause your video, be sure to practice that. Normally I give you the diagram in class and we practice that. And I know I've sped through these last few slides, principally because it's not all core learning. So those are your 3 main features. Hopefully you can identify those. They're in colour. Esca is blue because it's a feature of fluvio-glacial deposition, so water and glacier, and terminal and drumlin are just because of glacier deposition. And here are your answers if you're ready. So there we go. And that kind of gives you the kind of last feature, which was a cane. Sorry, not a cane, an Esca and its formation, and covered the rest of that. Any questions at all, please do get in touch with me. I'm just showing the last little few bits here, what these features are, and really reminding you about a few extra detail points that aren't necessarily essential. With the show me board, or in your notes, actually, what we'll get you to do, your last little task, what do we call material sorting into layers? It's a little quiz you can put down into your Google Doc or on your notes and send me a picture. What deposits first in a meltwater stream? Draw an Esca, what it would look like post-glaciation. What does an Esca tell glaciologists? What do we call a hollow in the ice that meltwater disappears down into? What would fluvio-glacial material look like? And these are similar questions actually, so I've got 2 sets. So that kind of ends the lesson just there. So if you submit to me your pictures of an Esca with your annotations around it and some answers to your quiz questions, that will finish us off for the lesson for today. And as always, if there's any questions whatsoever, please get in touch with me in Google Classroom, and you can add comments to the assignment, and you know my email as well. Thanks.